Today, we're going to speak about grounded generation and retrieval augmented generation, and we're very, very excited to announce a number of launches. There are some new APIs coming and some improvements in existing services, and our goal is to make it possible for you to build grounded generative applications faster and easier using those services. So I will be joined today by Guangsha, who is a product manager in the same team, who will actually give you a demo. Fingers crossed, everything will go fine. And after that, we will be joined by our guests. Kamal, Khilnani, and Bali, Mangat will tell us about their experience building generative applications within Charles Schwab. And Mark Zarka will talk to us about his experiences building such applications for Deloitte internally, but also for Deloitte's customers. So generative AI is opening up new opportunities for businesses to improve productivity and to differentiate, right? Knowledge agents and chatbots and employee assistants and customer assistants, next generation search. There is a range of possibilities. And our focus as Google Cloud is to make it possible for you to build those applications in a way that fits your enterprise needs. And a few things have to come together really for moving from like a very promising Gen AI prototype to an application that can actually work in an enterprise setting. And a big part of this is grounding. And by grounding, I mean the requirement for generative applications to have reliable access into the right enterprise data in order to produce answers which are up-to-date, accurate, and consistent, right? So, and for the builders of such applications, it is important to be able to verify that the applications behave indeed in a grounded way. And of course, there is a need for control, that everything goes the way you decide to go for such applications. And the whole thing has to be balanced against the need, of course, to have speed for development and to manage the performance issues and costs. So there is a bunch of things that have to come together, in addition to actually realizing the actual idea you want to build. So grounded generation is not, of course, a single linear recipe, right? But here we show a few steps that we see they're kind of coming together most of the times in most of those applications. You need to process documents that can vary in terms of formats and complexity and so on. You need to have an embedding and indexing strategy in place. And of course, you have to have the right embedding models available for high quality. You need an indexing and retrieval engine. And then during retrieval, in response to user questions, you need to be able to rank the most likely the answers to the question high enough so that you can generate the most appropriate answer. So, and at the end, of course, especially if you don't want to become news headlines, it's very useful to be able to actually validate that the response is indeed grounded to the facts. So, and to help you with this, we have a strategy to meet you with solutions where you are, right? On one side, in terms of simplicity, we have our Vertex AI Search, which is an out-of-the-box application. It can handle a range of document formats from a range of different sources, and it provides the solution end-to-end, from ingestion all the way to generative answers. But sometimes you want to build something that fits your exact needs. You have the need for controlling it the way you want, and you want to implement specific specialized requirements. So today we want to announce a number of new things we're bringing. to help you exactly for this kind of DIY use case. We are launching a new document processor that can handle a variety of complex document formats. There are significant improvements coming to our text embedding models. There are new capabilities for vector search that allow developers to build higher quality applications. We're launching a new semantic ranking API and a new grounded generation API, which is based on the power of Gemini. And finally, a check grounding API, which is verifying a statement against a number of facts, marking what parts of the statement are supported or not by those facts. Let's go through each of them in a bit more detail before we go into a demo that shows how actually everything comes together in a real application. So, first of all, document understanding. Documents can be quite complex. There are domains with very complicated document formats. You see some examples here. For example, financial statements with multiple sections and tables with different nature. And you have scientific documents that include multiple structural elements like graphs, like tables, like equations and so on. And then you have manuals where you have solutions to a problem that come in multiple steps, including sometimes visual elements that are part of the solution. So our new layout parser is part of our document AI suite. It parses documents from different formats and extracts the relevant structural elements, understands the full structure of the document, and it comes together with a chunking functionality that is able to do smart chunking in the sense that it produces chunks that are aware of the document structure and the document hierarchy. And you can use it as a building block because you can consume the output of this parser and build your own specialized processors on top of this. And let's see an example of how exactly it works. Here we have a 10K report that contains, like there is a heading, a section with a heading, a number of paragraphs. Some of those have lists, some of those include tables, and so on. So what the API does is it creates that structure in the middle. There is a section with a heading, and there is a list, and there are all these different blocks that are recognized in this document. And then the chunking function can actually use that structure to produce chunks which are consistent with the structure of the document. No more chunks that are cut in the middle or including the wrong elements. You see here, for example, the chunk number 1. It contains that list properly put together with the title of the section. And chunk number 4, which contains, again, there is the table, an associated paragraph next to the table, and in addition, you still have the title of the section, which gives a very useful context when you want to do retrieval or arson generation based on that chunk. The presence of the heading gives you additional context. So moving now to text embeddings, which is the next step. Normally, after you process the documents, the quality is very important. And today we are announcing some significant improvements in our Gecko embeddings. There are significant performance improvements. The updated models are now featuring towards the top of the corresponding leaderboards. And they have this nice property that you can dynamically alter the size of the embeddings. If you have the need for high precision, you can use the whole embedding. But sometimes you can trade off, in simpler domains, you can trade off some of the accuracy and benefit significantly in terms of requirements for storage, for compute, and for memory. And of course, the embedding API comes with the ability to tune embedding models. You give a bunch of examples from your domain, and you improve the quality of the generated embeddings to improve actually retrieval. So after you have done this, you need some place to put those embeddings, right? And we have our vector search, which we believe is the leading solution for embedding search in the market at the moment. It has really unparalleled scaling capabilities. It can have sub-10 millisecond latency for up to billions of documents. And it's very cost effective at the same time. We have benchmarked against some of the popular solutions in the market, and it can be up to 4 times more cost effective for the same type of workload. And that's not a surprise, because this is a technology that we are using for some of our planet scale applications. YouTube is using this technology, Google Ads is using this technology, and this is part of the reason why we are so confident about the scaling and performance capabilities. So it has query time filtering, of course, and it's very easy to get started with it. We have invested a lot on improving the onboarding. Today we are enhancing this product. There is an upcoming launch in the next few weeks, adding hybrid search. And why do you need hybrid search? We all know the limitations of keyword search, right? Keyword search ignores the semantic relationships between words, and therefore it leads very often to quality losses. And that's why we have embeddings, right? Because they kind of model that semantic similarity between pieces of text. But embeddings have a limitation on their own. In cases where precise retrieval based on keywords is important, then embeddings might not be able to actually provide the required accuracy. A good example of this is, for example, when you are looking for a specific product code, or when you have specific terminology that is not understood by embeddings, right? Company-specific terminology, acronyms, and things like this. In that case, embeddings don't provide the right retrieval, which materializes as basically quality losses for your applications. So hybrid search combines the two. It allows you to combine the semantic similarity with precision for keyword-based retrieval. You can balance how the two things are taken into account, and it can lead to much better performance in specific domains. So now, after retrieval, a frequently forgotten or ignored part is ranking, right? In most of those, RAG in 3 steps, introduction guides, the importance of ranking is not mentioned at all. However, it is really important, especially in certain cases, for ensuring good quality. And today we are launching a semantic ranking API. And I think this example demonstrates why this API is important, right? So we have a very simple question: how to fix a leaky faucet, right? And you have a bunch of statements which you can assume has been retrieved by your corpus. And all of them are related to the question. And you see in the blue bars, these are real numbers. The embedding similarity is pretty close between all the statements. And actually the score of the highest scoring part is not the one that is answering the question. It's related to the question, but it's not answering the question. In contrast, when you use the ranking API, you see how it nicely discriminates between the different answers and scores high the answer that talks really about the solution to the problem, which is what the query goes about. So the new API is available in preview. It's powered by a specialized model specifically for this task of ranking. It's faster and more accurate and cheaper than using an LLM, right? And you can use it to build your own RAG solution with it, or you can actually use your own retrieval, your existing retrieval engine, retrieve a lot of documents, and then use that API on top of it in order to re-rank and have the most relevant results first. And that's a practice that we use a lot within Google and in most of the domains where there is a lot of data involved. You have the retrieval stage where you go from the millions of documents into the a few hundreds, and then you use a more expensive ranking step to re-rank those results with respect to how useful they are for answering the question. And this is what the ranking API is doing. So it's a pretty simple API to use. It's a stateless API. The input is your query, as you see here, and the pieces of content that you want to rank. And the output is, again, this set of records, which is re-ranked, and each of them has a score that indicates how relevant they are for the query. Now, you have your nice list of chunks or documents. The next step is generation. And here we are launching a new grounded generation API in private preview. It works rather simple. You provided a prompt, and it's like a preamble, and then your query, and you provided your sources. The sources can be, at the moment, Vertex AI search as a source of documents, or you can sideload information. For example, you have your own retrieval engine, you retrieve a bunch of results, and then you can pass them over to the model, and the model produces a grounded response with citations, referencing the inputs. So the grounding API uses it's a specialized fine-tuned version of Gemini, and which is tuned to produce fewer hallucinations and produce reliable citations. And it has the additional advantage, if you plug a source, it also takes over the task of mapping a prompt to the queries for that source, which it might sound simple, but there is a lot of tuning that is needed to make sure that mapping is done right to retrieve the most relevant things for a specific prompt. Currently, as I said, it's supporting Vertex Search. Our plan is to extend it so you can plug any third-party retrieval engine as a kind of a plugin to the API. So you can see here the interface of the API. You pass the content, which is the query, and a configuration for the different sources, or the elements that have to be used. And on the right side, you see the response, and to the extent that it could find citations, also the list of the citations. And then finally, the check but trust but verify kind of step, the check grounding API, which solves this very simple but very important problem. I have my facts, I used my LLM to produce the answer, and now what's the quality of the response? So does it correspond to the facts? Are there hallucinations? This is what the check grounding API is trying to solve. You can provide to this API up to 200 facts with a total of up to 400,000 tokens. And you can use it in your RAG applications to ensure that the output it's indeed grounded. Or another very useful application of this is when you are iterating on the quality of your answer generation, you can use it as an autorator to basically pass the responses, have the API score them for factuality, and then therefore measure how the quality of your solution is improving. There is a restricted preview version of a second feature of this. In addition to providing finding statements which are supported by facts, it also will have the ability to go sentence by sentence and find out contradictions right? Like this statement actually contradicts some of the retrieved results. That's quite helpful in domains where not all information is consistently talking the same way about the topic. So, and how it works here again, there is a situation, tell me about the movie Inception, there is a number of retrieved facts, you have an LLM, it produces an answer, and you see here, after applying the API, some of the pieces of the answer as detected, it goes sentence by sentence and checking it against the facts. Some of the pieces are detected to be grounded, and you have the reference to the facts, and some of those say, no, this is not a grounded statement. So, and with this, after talking about all those APIs, I will invite Guangsha to come on stage and show us how everything fits together to build an actual application.
Thank you, Dimitris. Hey, I'm Guangsha Shi. I'm also a product manager on the Vertex AI team. So Dimitris today just introduced a suite of new APIs and also updates to the existing service, which you can leverage to build your own RAG solutions. Now, today in this demo, we will also go through one example altogether to better understand how we can leverage all these individual APIs and build a Gen AI application from scratch to produce very accurate search results and grounded answers. So in this demo, we're going to focus on two data sets. One is the 10K filing data sets with PDFs, 20 PDFs from different tech companies and between the year of 2019 and 2022. The other data set we're going to use is the Wikipedia data set, which has a 20 HTMLs with a focus on a few key concepts and figures in physics, such as superconductivity and Albert Einstein. Right? Once we have these documents, we're going to process these documents using the document AI layout parser. Right? So this whole process may take 1 or 2 minutes. So we're going to here use the load the saved process documents for our demo. Because the 10K PDFs typically are longer than our Wikipedia pages. That's why in the end, we end with more chunks for the 10K data set than the Wikipedia data set. Now here, let's take a look at a few examples to better understand what the document parsing results and chunking results look like with our layout parser. So this is a PDF page sampled from the 2022 10K of Alphabet. And you see this document, this page focuses a bit more on Google spending on research and development, sales and marketing, and a few other areas, right? And all this detailed information, they are summarized in both tables and paragraphs. Our layout parser is able to detect headings, tables, and paragraphs. Now for the tables, we do not only get the rows, columns, and the cell values correct, we also have this row span and column span to represent very complex table hierarchies. And when we chunk the documents, because we already know the layout information, right? We are trying our best not to break the chunks by splitting the middle of any small section or splitting the middle of any element. And all these headings, tables, lists, they are represented in Markdown in order for the downstream embedding models and the large language models to better understand them. And for the Wikipedia page, with this table of the number of Nobel Prize winners in physics by country, again, we get all these headings and tables correct. And these headings and tables are represented in Markdown in a chunk. Once we have the chunks, we can also call the large language model or any kind of post-processing tools to extract the key information from the chunks. So in this demo, we also use the large language model to extract the key fields, such as the trading symbol and the year from the first page of the 10K documents. So potentially, these extracted fields can also be used for filtering and other purposes in the downstream. So here we have completed document processing, right? Now, in order to enable search on these chunks created, the chunks should also be converted to embedding vectors, and we need to create indexes based on these embedding vectors. This part is being done with our latest version of embedding model and our vector search. So here we initialize a vector search retriever, right, based on the embeddings we have. And then we also create a data store to store the raw text of the chunks. Now, we create embeddings and save the embeddings of the chunks in our vector search index, and we save the raw text of the chunks in the file store, in the data store. Okay, so here comes the more exciting part of the demo. We're going to connect our indexes with serving APIs and test a few queries in real time. Right? In order to do this, we first create a chain to connect our vector search retriever and ranking API. And this is also following the convention of long chain. Once ranking API determines the top K results, the top K chunks, we send the top K chunks to the grounded generation API to create a final answer. So here you can see that in this function, we define a much bigger chain that connects all the small chains, including the retrieval ranking chain, the reformatting, and also the grounded generation. Grounded generation is going to take the top K chunks as facts, as input, to produce the grounded answers. And in this demo, we retrieve 25 chunks from vector search. We re-rank all of those, and we use the top 10 chunks from ranking API as facts, as input to our grounded generation step. Let's take a look at the 10K documents first, right? Now, if you remember, we presented a PDF page about Google spendings on research development, sales, and a few other areas. So why don't we ask this question first? How much did Google spend on R&D in 2021 and 2022? Let's run this in live time. Okay, so our grounded generation API got the correct answer, right? And if you look at the citation, we can see that the correct answer is in this table, in this chunk, right? These two numbers. Let's try a different question. How much more did Google spend on sales in 2022 compared to 2021? Let's see what we have. Now, for this query, we did not only generate individual numbers for the 2 years, but we also produced the difference between them, right? Now, if we take a deeper look into the retrieval and the ranking results, we're going to have more interesting findings. So here you see, actually, our ranking API was able to push this most relevant chunk from the second place to the top position. The left side is retrieval, and the right side is the re-ranked results. Now we have confirmed that our solution works very well on the 10K documents. Let's now switch to the Wikipedia dataset. Let's ask this question first. Which European country has the largest number of Nobel Prize winners in physics? I'm not sure anyone knows this in our audience. Okay, let's see what it says. Okay, so our grounded generation API was able to look into this table, right? Remember this table we presented before for the Wikipedia page? It understands that United States is not a European country. European Union is not a European country. So Germany should be the right answer, right? So Germany has the largest number of Nobel Prize winners in physics. We can play with a different query. Did Oppenheimer and Einstein ever work together? Okay. Now, if you have watched the movie Oppenheimer, you would probably know that they did have some overlap, right? But let's see if our solution can get it correct. And yes, Oppenheimer and Einstein worked together in the Institute for Advanced Study in Princeton. Now, if you remember, there was a very famous scene from the movie Oppenheimer that where Oppenheimer was talking to Einstein by the lake in Princeton. Remember that? And we can take a look at the retrieval ranking results as well. Now, for this query, our ranking API is also very powerful, right? It pushed these two most relevant chunks to the top 2 positions, right? All from the ranking API. Now let's try our last query, last question. Also, hopefully an interesting one. Is Schrodinger's cat alive or dead? And we were able to figure it out, right? So Schrodinger's cat is a thought experiment in quantum mechanics to illustrate the paradox of superposition. This is correct, right? And this is because our grounded generation API is able to provide grounded answers with citations. Now, what if you get answers with a different generation model, right? What if you get some statement from different source? How can we validate if they're grounded or not? So actually, you can use our chat grounding API as Dimitris introduced. So the chat grounding API takes the statement and the facts as input, and it helps you to verify if the answer or the statement is grounded on the facts. So let's first take the correct answer as example, right? Let's say Schrodinger's cat is both alive and dead. Let's see whether this is grounded. Now, as we expected, this statement gets very high grounding score, right, with all these nice citations. But if you change it to some relevant but made-up statements, such as Schrodinger adopted a cat in Las Vegas, or Schrodinger's cat enjoyed hanging out with Einstein, then there are going to be no citations, right? And your grounding score is going to be very low. It's going to be below 0.5, which indicates that the statement is not grounded. It's not really supported by the facts. Now, this is all for my demo. After today's session, I hope you can also explore and play with these APIs and have fun building your own RAG solutions. And of course, please feel free to bring your feedback to us. Thank you. Now, I will hand it back to Dimitris.
Thank you, Guangsha. We're lucky there was no demo effect hitting us on that one. So now I would like to invite on stage Kamal and Bali, who will talk to us about their experience building similar applications for Charles Schwab.
Thank you, Dimitris, and thank you to the Google team for inviting us out here at Google Next to talk about our use cases. So before I start, let me give you some background about Charles Schwab. So as most of you already know, Charles Schwab is the largest publicly traded brokerage firm with over 7.1 trillion assets under management and 35 million active trading accounts. So like talking about our first use case, so as you know that we are a financial organization and we are bound by several regulatory constraints. So we wanted to pick a use case that is less risky and at the same time provides a lift for our end users. So with that, we picked up a use case that is knowledge retrieval or knowledge assistant. So in current state, we have our call center reps who look at the data in SharePoint. So they serve through thousands of PDF documents and answer to the queries for our customers. And while the call center reps are trained to do that, many times it requires them to look at multiple documents, and that impacts the average handle time for the call. And also, sometimes it also requires the call center reps to be trained, or tenured or experienced reps have to attend certain kind of calls. So in order to address that kind of a situation or scenarios, we built the knowledge assistant application. So in this case, the knowledge rep can, the call center rep can ask the question to the knowledge assistant application, and in that, it does the search for the in the vector database for the labeled data. A context is built, and that in conjunction with the prompt is sent to the LLM and for summarization. And when we get the summarization, it's with the citations. So in that case, if the call center rep wants to look into the details, they can delve into the details based on the citations. So at the high level, the architecture that was used, it's a kind of a hybrid model of Vertex Search and LLM built on the RAG foundations. And we used some out-of-the-box features that are built into the Vertex Search, like extractive segments. So what extractive segment does is actually it extracts out the verbose context in chunks. That is then sent to the LLM, and then LLM in turn sends the response back in a summarized manner with the citations. So while doing that, what we saw is that like Vertex Search overall provides almost 12% better response or helps get a better response from the LLM. And that's the best benefit of using some of the out-of-the-box features. And while our first use case is more focused on the out-of-the-box capabilities of Vertex Search, I think the second use case that my colleague Bali is going to talk about is where actually you'll see the benefit of some of the APIs that we talked about in this session. So over to you, Bali.
Thanks, Kamal. Thank you, Kamal. Thank you, Guangsha. Thank you, Dimitris, for having us. Good to be here. As Kamal said, we've been on this journey for almost 14 months now, and it continues to be an exciting journey. We're learning a lot. This space has so much hype, so much potential, and also a lot of risks come along with generative AI. And Google has been a great partner along the way, helping us understand the different capabilities, some of them really early, some of them GA, and we've learned a lot over the past 14 months. So I'll focus on what we're doing post what Kamal mentioned, right? Our first use case was Knowledge Assistant, which really focuses on helping our call center reps be more productive, more efficient, provide a better client experience. But now we're getting into research, right? And you saw some of the research documents in the demo. They can get quite complex. You have tables, you have charts, and the idea is to help our financial consultants and advisors ask a question where they can better prepare for client meetings. They can even ask questions that are personalized to a client's portfolio, to their goals. And then also, we're looking at summarizing client meetings and then providing some follow-ups that can help the financial consultants. And the documents come in all kinds of flavors. We have PDFs, we have HTMLs, we have tables, charts, graphs. And these documents, when they were authored with the human being in mind. They were not authored for a machine to be able to understand. And you saw some examples. So really excited to look at some of the features and functionality that Google's coming out with, and we're also already using. And the other piece I'll quickly touch on is that's different, is the freshness of the content is really important to us in the second part of this journey, right? The first part, the content was what we call evergreen. Now we need fresh content because perspectives, opinions about how the market is behaving, the economy changes over time. And then really, once we have all the context collected, the LLM has the easy job of taking the context and then generating an answer based on the prompt, based on how we stitch together different elements of the documents, and then guardrails, right? The guardrails become really important because in our industry, we have to make sure that we're grounded in facts. So the last step here is really the validation along the way. So the grounding API is really important for us to help make sure that our answers, our generative summaries of the answers is grounded in facts. Thank you.
Thank you, Kamal and Bali. It's really exciting to see what happens in financial services. It was a pleasure working with you. I want to invite here Mark now to talk to us about his experience with Deloitte building similar applications.
Awesome. Thank you, Google, for having me here. So what I want to do now, well, before I go into what we're talking about, real quickly, Mark Zarek, I sit in our strategy practice, have a few roles. One, designing the future of US consulting in terms of how we do work, in terms of how we deliver outcomes, as well as working in the market in some of our more nascent implementations and applications. So a few things I want to talk about really briefly. First one is just how do we actually think about application engineering using AI, and then thinking about that for our clients as well as ourselves. Secondly, quickly touching on, well, why is Vertex such an important part of that equation? And then lastly, we'll touch on some real live use cases in terms of what's been built. So as a consultant, my role and our role is to figure out not only how do we talk about use cases, value, or even telling you how it depends based on the situation. It's actually going into how do I actually generate real outcomes based on the situation. Those outcomes are defined by a key set of application engineering patterns that we've defined. At the lower bound, everyone's been playing with RAG and being able to say, how do I get better answers out of my questions and data sets? And thinking about, is there more interesting things I can embed into workflows? And at the upper bound, we've actually started building and have built things such as cognitive systems that evolve and change over time. So it actually replicates the way that I think, and will actually be able to get to outcomes in hours, not days or weeks. And then you can think about how work will actually be delivered, rather as opposed to being sequential. Things will be iterative over time. Now, those two things, the common element there is that I can rely on something like a Vertex to be able to provide me, one, really cutting-edge frontier models, being able to provide me with the core data engineering required to say, can I trust the outputs associated with these applications that we're building? And then if we dive into that, the cognitive system that we've designed, if I think about me as a consultant or a financial analyst or an engineer, we can actually start to build in patterns that over time, I can actually think about, if I build on a foundation that is Vertex, the system itself will evolve, and then also the underlying foundation will evolve. And that symbiotic relationship is one that I'm really excited about, to say, if we have something where Vertex powers our systems and the way that we do work and the way that we realize outcomes for clients, that'll actually change the foundationally the way of getting to the unit of work done. And then lastly, what I want to do now is just quickly talk about some real-life applications that we built. So at Deloitte, if we want to upscale our practitioners who are not necessarily well-versed in this net new tech, how do we get people to understand what AI is, what the different components are, because they have to answer questions for our clients. Using something that we've built, which is called AI Tech Navigator, I can use Vertex because I trust the outputs to be able to tell our practitioners how do we actually understand what the different pieces and parts are in a trusted way. Second, a couple actual client implementations. So a large life sciences company, how do we actually do M&A work in a way that's trusted and differentiated? So in my pre-M&A days prior to AI, used to have to do diligence work. A lot of that was, could I actually get to all the different relationships in a way that was actually trusted and be able to say, is this a good target? Is the valuation correct, et cetera? We are actually able now to actually accelerate that upfront process because, one, we trust Vertex to be able to provide that, and the client actually trusted the ability to have that implemented. And then lastly, I worked with the derivatives exchange where we actually had more complex workflows using Vertex to be able to power that, but you actually could extend the enterprise to be actually interact with the customer base. Again, the interesting part with Vertex was that we were actually able to ensure that the output was trusted in a way, so that one, not only did it actually not decrease customer conversion, you could increase customer conversion, but you also could add leverage to the end customer to be able to drive up revenue. It's not just a cost productivity play, it's actually a revenue play. So just a few examples. I know we're tight on time, but last thing here. Again, thank you, Google, for inviting us. And I wanted to say at the very end, if you get a chance, there'll be a QR code that comes up. If you scan the QR code, we'd greatly appreciate if you could give us give a ranking on our session. But thank you for your time.